we have been graphing linear equations. Now, a linear equation is in the form of y equals mx plus b. Okay, that's how we know it's a linear equation. So if we have y equals 1/3 x plus 2, we know that's linear. Now, if it's linear, what does the graph look like? Straight line. Yeah, it's a straight line. Okay. How do we graph this?
Isn't it? You start at 2.
Start at 2, right? Y-intercept of 2. Good.
And then up 1 to the right 3.
There you go. Up 1 to the right 3, and there's our line. Okay. No. Okay, there's our line.
Oh.
Yes?
I emailed you the other day.
Okay, we are focusing on this. I'll be happy to answer all your individual questions later. Right? Focus.
So is that up 3 or
Up 1 over 3. So if I had the equation 3x plus 2y equals 6, what type of graph would that be? What would it look like?
you said 6?
That is also a linear equation, right? So we know that that's also going to be a straight line. Now, the way that I know that is by looking at the exponents. The exponent of the x is a 1. The exponent of the y is a 1. That tells me it is a linear equation. So without graphing it, I know that this is going to be a straight line. Okay? As opposed to something like this, y equals x squared plus 3. That will not be a straight line. That's a quadratic equation, and quadratic equations look like this. Does anybody know what that's called? It's a parabola. It's called a parabola, okay? So that's what we're going to work on today, graphing parabolas. So a parabola is the shape of a quadratic equation, and this is the form of a quadratic equation. You should be writing this down. This is the standard form of a quadratic equation. Okay. That's the standard form of a quadratic equation. Just like with linear equations, when we see the equation, we know the general shape of the graph. When we see a quadratic equation, we know the general shape of the graph is a parabola. It's one of my favorite math words just because I like to pretend that I can speak other languages. Parabola, parabola. You can make it like all different languages. Parabola, right? I don't know why I did higher, but parabola, 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 parabola. Okay. So anyway, one way that you can remember that word, I think of it. I know that it's not actually what it says, but parabola, a bowl. It looks like a bowl. Okay. It looks like a bowl. So parabola, parabola, looks like a bowl. Okay. Okay. So how do we know? Well, if we look at our equation, let me just write the linear equation below it. Okay. If we look at the quadratic equation, we see that the x is squared. Okay, everybody paying attention. Gianna, wake up. Right? The x is squared. Is the y squared? No, just the x. So if there's an x that's squared, but the y is not, it is a quadratic equation, and the shape is a parabola. If they're both squared, it is not a quadratic equation. In fact, that's a circle. So if they're both squared, it's not quadratic. We will talk about these later. Today we're working on quadratic equations. Okay, so let's look at some of the properties associated with a quadratic equation. Okay, I'm just going to look at a very basic equation, y equals x squared. I know that's quadratic. How do I know it's quadratic? Because the x is squared. What's the shape of this graph? Parabola. 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 You need to know that word. Parabola. Say it. Parabola. Say it. Parabola. Everybody say it. Parabola. I want everybody. Parabola. Okay, say it with a different accent. Parabola. 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 Okay. What's it called? What's it called? What is it called? What's it called? What's it called? I'm going to keep saying it till I hear you all say it. What's it called? Parabola. Parabola. Thank you. Okay, it's called a parabola. All right. Here is your basic y equals x squared parabola. It's not a dotted line. I'm just drawing it like that initially because it's really hard to draw them on this board. Okay. This is your basic y equals x squared parabola. So we're going to talk about this a little bit. First off, the ends have arrows. They're going to continue going. Okay. If I were to exaggerate this and kind of draw it like this, right? This is a real short and fat parabola. Okay. We see that the ends continue to go out and up. Okay, they continue to go out and up in this particular example. Bless you. Bless you. Bless you. Woo! Okay. So the ends continue going. Okay. Also, this is a very important part of a parabola. We have what we call symmetry. Symmetry, okay? Symmetry. What does symmetry mean? Or symmetric, what does that mean? It's the same on both sides. Yes, right? Right? We are symmetric, right? If you cut me in half, both halves would be the same. Don't try it. Okay? Take my word for it. Right? We're symmetric. Okay? Can you think of a shape that is symmetric? Square. Anything else? Circles, a rectangle, right? Most of our shapes are symmetric. Okay? If you cut them in half, they're the same. So the parabolas are symmetric. Okay? They have an axis of symmetry. Right? In this case, my axis of symmetry is right there along the y-axis. Think of it as folding the graph on that line. If I fold it on that line, the right side and the left side are the same. So for instance, if I had a point right here and I fold it on the axis of symmetry, then I will have another point right here that matches. Okay? If I have a point here, when I fold it, I'll find its matching point right there. Okay? So parabolas are symmetric. They have an axis of symmetry. We also have what we call a vertex right here. This is called the vertex. In a parabola, the vertex is the highest or the lowest point. In this case, it's the lowest point. Mary, what would a parabola look like if it had a highest point? If the vertex was the highest point, what would the parabola look like? What is it? They're upside down, yeah. If I had an upside down parabola like this, okay? If I had a parabola going that way, then the vertex would be the highest point, okay? So when you look at the parabola that I graphed right here for you, this yellow one, it has a minimum value, but it does not have a maximum value, okay? If you want some examples in the real world of parabolas, okay, one of my favorite examples is when we have maybe a cannon firing something or a kicker kicking a ball, right? Okay, that's a cannon. Yeah, it's a cannon. Okay, maybe it's not. I don't know what it is. It's a ray gun. It's a ray gun. Okay, right? We get what we call a parabolic path. Projectiles make a parabolic path. Okay, learning about parabolas is so important because if we can identify the vertex, then we know the maximum height of this object, right? If I'm kicking a football, okay, if I'm trying to kick a field goal, right, so here I'm kicking, that's going to be a projectile. It's going to have a parabolic path, okay? I need to know that maximum height because I need to know it's going to clear the crossbars, right? Have you ever seen someone try to kick a field goal and it comes up too low or too short? Okay. Clearly that's an issue. So we need to know that. We need to know the maximum height. Okay. Sometimes we might start up high and then come down, right? So that vertex is one of there's some really important features of parabolas. The vertex is one of those very important features because we need to know where that maximum or minimum height is, okay? And it's not always talking about projectiles. It might be talking about, maybe we're looking at just part of it. We might be talking about financial growth, okay? So this is a real important function. Okay, so let's look at some examples. Let me see if I can clear some space here. I like my football picture. How about baseball, right? We hit that ball. We've got a projectile. Okay, so let's look at the equation y equals x squared. That's what I just graphed, right? X squared plus 2. What happens if I add 2 like that? What happens to my graph? Remember when we learned how to graph absolute value equations? What happens when I add 2? Anybody remember? We go up 2. Yeah. So here's just the plain old x squared. I'm going to move it up 2. And now we have a parabola that looks like that instead. Okay, that's my y equals x squared plus 2. It's going to slide up 2. Okay. How about y equals x squared minus 3? Where's that going to be? We're going to go down 3. Yeah. Going to go down 3. Notice it's the same shape. Same shape. Still symmetric. We just slid it down 3. Okay? Everybody putting this in their notes? Do they have notes to refer to? Okay. Okay. What happens if I do y equals x minus 2 squared like that. Who remembers what happens with that one? Right? When I add it to outside the parenthesis, let's pretend that this was a parenthesis, it went up to. What happens when I put inside? Sideways, yeah. And it's going to be the opposite of what's here. So it's going to move sideways, but it's going to move to the right 2. So we're going to go over to positive 2. And my graph is going to be there. Later on, we'll learn why it goes the opposite. Okay?
So if it was positive, it would go negative.
Yes, exactly. We did it with absolute value equations. Yes. So if I have y equals x plus 3 squared, then it's going to move 3 to the left, like this. Okay? Okay. What if I had, any questions on that? Okay, what if I had y equals x plus 2 squared plus 1? What will that one do? So what's the plus 2 inside the parentheses do? Moves it to the left 2. And then it's going to go up 1. Right. What is the vertex of that parabola? It's this point right here. What's the coordinate of that point? Almost negative 2, 1. Negative 2, 1. Okay. Let's look at another one. Let's do, oops, I just moved the wrong slider. Okay. Let's do y equals x minus 3 squared minus 2.
Miss Murray?
Yes.
Heather, can I have Allie Bradley to the front office for just a moment?
Okay.
Thank you.
So what happens with this graph? To the right 3 and down 2. Okay. What's the vertex of that graph? What is this point right here? 3, negative 2. Everybody see that? Okay. This time, y equals, we're not going to graph it. We'll do x plus 1 squared minus 3. What is the vertex? Look at the patterns here. Look at what we had. Here we have x plus 2 plus 1, right? So the y coordinate, right? The y coordinate of the point is this one, this number. Plus 1, this is minus 2. The x value is the opposite of this one. Minus 2 plus 3. So what's my vertex of this one? X comes first. So negative 1, negative 3. Remember, your points are always in alphabetical order. Right? So your vertex is negative 1, negative 3. Right? Look at this equation here. Y equals x minus 5 squared plus 2. Right? The vertex will be, we're going to take the opposite of that, so it's 5, and we leave that alone, 2. 5, 2. Okay? Because if I started with just y equals x squared, right? If I started just right here, I would move 5 to the right, and then 2 up. And that would put my vertex right there. Does that make sense? Okay, this is what we call the vertex form of this equation. Okay, the vertex form of a quadratic equation looks like this. Y equals x minus h squared plus k. Now, I didn't introduce that initially because the h and the k kind of scare everybody, right? So we looked at a bunch of examples and we can see how it moves, okay? So when the equation is in this form, my vertex is just simply going to be hk. That's my vertex. So the advantage of this form of the equation is that we know where the vertex is right away just by looking at it. We don't even have to graph it. We know where the vertex is, okay? So if I look at, well, let me just go back up to the examples I have, right? So if we look at these graphs, right, is the vertex representing the minimum or the maximum point? Is the vertex representing the minimum or the maximum point? The minimum, yes, right? If the parabola opens up like that, the vertex will be the minimum point. If it opens down, if it's an upside down bowl, the vertex will be the maximum point. Okay? When do you think the the parabola will be upside down? What would I have to do? You have to flip it. So what's going to make it flip? No, you're thinking sideways. That would be a sideways parabola. Yeah, so here's my y equals x squared, right? If I have y equals negative x squared, it's going to flip upside down. Okay, so if it's negative, it flips upside down. Okay. Okay, let me just pause the video for a minute. Google Classroom, there is a worksheet called Vertex Form. There's 4 problems. I would like you to do those 4 right now, and then we're going to go over them. Okay, there are 4 problems. Okay, put up in your Google Classroom. Listen, please. Okay, for each problem, is everyone listening? For each problem, you're going to state the vertex. You're also going to state the axis of symmetry. So let's take a second to look at that, okay? Because I don't think I did that with you. Right, look at these parabolas here. Okay, the white one. Okay, look at this parabola right here. Where would my axis of symmetry be on this white parabola? Yeah, the axis of symmetry is going to be right here. This is my axis of symmetry. Okay, I need everybody to look up. Stop working on the worksheet. Look up. Okay, this is my axis of symmetry. So in other words, if I fold the paper, right, then the right side and the left side will match up. It's called my axis of symmetry. Now, the axis of symmetry is a line. It's an imaginary line. It's not actually part of the graph. We would say that our axis of symmetry is the line x equals -2 because it goes through that value on the x-axis. X equals -2. That's my axis of symmetry. Look at the blue one. Okay, here's my axis of symmetry. This is going to be x equals, well, where does it go through the x-axis? 3. That's the axis of symmetry. Okay? I want you to look at another one. Don't work on the worksheet yet. I need you paying attention. Okay? Let's look at another equation. Y equals x minus 2 squared plus 1. Okay, where's that vertex going to be? 2, 1. Right, we're going to move over to the right 2 and up 1. So here's my parabola. We're sketching this because it's not exact yet. Here's my axis of symmetry. What's the equation for the axis of symmetry? X equals 2. Good. Notice, okay, everybody, put your pencils down and look up here. Pencils down. Pencils down. Pencils down. Look up here. This is so important, okay? Notice that the axis of symmetry comes from the x value of the vertex, okay? The axis of symmetry is the x value of your vertex. Look at these examples up here. My axis of symmetry is the x value of the vertex. Look at this, axis of symmetry. What is it? The x value of the vertex, okay? When we go into the next part, that's going to be very important, okay? So, okay, I want you to do those 4 problems that are in your Google Classroom right now. I'm going to give you about 5 minutes. Yep.
Why would we get 5 minutes?
Because we got more to do. Okay. All right, so let's see. First one. Okay, sometimes the graph is confusing, the grid is confusing. You're only given a portion of it just to give you some space. Okay, so what's our vertex? Vertex is the point 3, -4. Okay, so we're going to go 3 over the 3 down to 4, and we're going to put our point there. What's our axis of symmetry? X equals 3, right? So here's my dotted line. I'm drawing it as a dotted line because it's not actually part of the graph. And then we're just sketching the parabola. The reason I'm saying we're sketching it is because we really don't know the shape. This could be a very skinny parabola like this, right? Or it could be a very fat parabola like this. We're going to do that next. For now, we're just sketching it, and then we're going to learn how to get a better idea of what it looks like. Okay? Okay, next one. Vertex is 4, 1. And the axis of symmetry, x equals 4, right? Make sure you say that x equals. So here's my axis of symmetry, 4, 1. And then we sketch it. Notice, where does the vertex always fall? It always falls on the axis of symmetry. The vertex is always on the axis of symmetry. We could say it like the axis of symmetry always goes through the vertex, right? So that's really important. Okay, the next one, what's my vertex? -2, 2. Mark, what's my axis of symmetry? Yeah, x equals -2. -2, 2. Draw my little dotted line in there. And There's my parabola. Okay. Last one. RJ, what's the vertex?
4, 2.
-2. Right? Don't change the sign of the y value. And my axis, Drew, what's my axis of symmetry? X equals 4. So we have 4, -2. Here's my axis of symmetry. And there's my parabola. Okay? When you draw the parabola, make sure it has that curve to it. Okay? It is not an absolute value. If you draw it with a straight line, that's an absolute value equation. It's not absolute value. You have to have that curve to it. Okay? Okay. So let's look at, what we just spent time on was what we call the vertex form of the quadratic equation. Okay, the vertex form. The advantage of the vertex form is that we immediately can identify the vertex and the axis of symmetry. Okay, so if I have y equals x minus 3 squared plus 2, just by looking at the equation, I know my vertex and I know the axis of symmetry. That's the advantage of the vertex form. What's the disadvantage? What's the disadvantage? Jesse, what was it you asked me?
How do we know what shape to make it?
Exactly. The disadvantage is that we don't know the exact shape. We don't know how fast it's going up. Okay, that's the disadvantage, all right? Let's take a 2-minute break before we continue on because I'm losing some of you. Okay, so we've looked at the vertex form, okay? Now we're going to look at what we call the standard form of the quadratic equation, okay? The standard form. Gentlemen, thank you.
2 minutes up.
The standard form. 2 minutes is well over, yep. Y equals ax squared plus bx plus c. That's what we call the standard form. Okay, the other one was the vertex form. What were the advantages of the vertex form? We could quickly identify the vertex and we could quickly identify the axis of symmetry. Okay. Okay, so let's look at an example. Let's say that we have y equals x squared plus, and we'll do 4x plus 4. Okay. Y equals x squared plus 4x plus 4. This is our example. So the first thing we're going to do is figure out the axis of symmetry. I know this is a quadratic equation and I know it's a parabola because it's a quadratic equation. How do I know it's a quadratic equation? Because the x is squared. The x is squared, okay? So I know it's a quadratic equation, which means it's a parabola, which means there's an axis of symmetry. We're going to use the formula x equals, because remember our axis of symmetry always says x equals something. X equals negative b over 2a. We're going to use that formula to figure out the axis of symmetry. So let's go back over here and let's figure out what a, b, and c equal. So what's a? A is the number in front of the x squared. So what is A? What number's in front of the x squared? 1. What's B? And what's C? 4. Okay? So our axis of symmetry is negative B. So that would be negative 4 over 2A. And A is 1. So we have negative 4 over 2, which gives us negative 2. So our axis of symmetry is x equals negative 2. So I'm just going to kind of plot that on my graph. I'm going to just put a dotted line right here. X equals negative 2. I find negative 2 on my graph and I put a dotted line through there. There's my axis of symmetry. Okay. Now, what did we learn about the vertex? The vertex is going to be a point. And what do we know about part of that point? Where's the x value come from? The axis of symmetry. So what's the x part of my vertex? Negative 2. Okay? Yes. Yes. No, that would be a different form. Depends on what form the equation is in. If it looks like this, you don't do the vertex stuff. Okay? Okay, so we have the x value. We need the y value. How are we going to find the y when we know the x? Plug it in. Y equals x squared. So what's x? Negative 2. So negative 2 squared plus 4 times x, which is negative 2 plus 4. Okay? So I plugged it in, right? My equation is x squared plus 4x plus 4. That's my equation. That's what y equals. So I plug it in. So that means y equals negative 2 squared is equal to what? What's negative 2 times negative 2? Jackson, what's negative 2 times negative 2? Positive 4, yes. Okay. What's 4 times negative 2? Negative 8 plus 4. Okay, what is 4 minus 8 plus 4? 0. 0. Everybody should be writing this down. So when x equals negative 2, what does y equal? 0. So there's my vertex. There's my vertex. So let's plot negative 2, 0 on my graph. So we go over to the graph and we go over to negative 2 and we go up 0. So there's my vertex right there. Okay? Now we're not going to draw it yet. Okay? The last part. Look, we found the axis of symmetry. We found the vertex. The last part is to find where it crosses the y-axis, the y-intercept. This part is really easy. It's the c value of your equation. So what's the c value? 4. So the y-intercept is 4. So I go to my graph and I go up to 4 and I put a point right there. Okay? So at this point, I have half of my parabola. Oops, that's really bad. try that again. I have half of my parabola. So it's symmetric though, isn't it? So just imagine folding it on this dotted line, I can find another point. How far away from the dotted line is this point? 2. 2. So let's go to the other direction. So I'm going to have another point right there. Now I have my full parabola. Yes. Yes. Okay. Let's do another one. Let's do y equals x squared plus 6x plus 8.
What is our quiz?
Next week. We can do it. You can do it. Okay. All right. So, what do we know just looking at the equation? It's quadratic. Yes. Do we know A? What does A equal? 1. How about B? How about C? Okay. A, B, and C. All right. I know something else just by looking at the equation. Anyone remember? I know the y-intercept. What's the y-intercept? 8, yes. The y-intercept, where it crosses the y-axis, is 8. So let me see. 1, 2, 3, 4, 5, 6, 7, 8. All right, I'm going to put a point right there. Okay? Now we're going to figure out our axis of symmetry and then our vertex. It has to be in that order. Okay, we're going to do the axis of symmetry and then the vertex. Okay, so x equals negative b over 2a. So x equals, right, what's b? 6. So it'll be negative 6 over 2a, which is 1. So x equals negative 3. Okay. Okay, so let's plot that point. We're going to go, what's going on here? Okay, we're going to go over to negative 3, and we're going to draw our dotted line there. Okay, I got my axis of symmetry. Now what? Vertex, yes. Now we're going to do our vertex. Remember, the vertex is a point. So it's got an x and a y value. What do we already know? X is negative 3. Okay. Now we have to figure out the y. So y equals x squared plus 6x plus 8. That's my equation. So what do I do? We're going to plug it in. Y equals negative 3 squared plus 6 times negative 3 plus 8. So y equals positive 9 plus negative 18 plus 8, which gives us, let's say 9 plus negative 18 is negative 9 plus 8. So y equals negative 1. That's the other part of my vertex. Okay. So now I can go back up to my graph and I can put my vertex on there. Negative 3, negative 1. There it is. Okay. So I have half of my graph again. How do I find the other half?
Go to 8.
Fold it, right? Fold it. So if I fold it, this is going to be 1, 2, 3 on the other side. Okay, it's 3 away on this side, so it's got to be 3 away on that side. So there's the other half of my graph. Okay. Okay. The vertex form, the advantage is that we can quickly see the vertex and the axis of symmetry. The standard form, what can we quickly see? The y-intercept, right? We can figure out the vertex, but then we get a better shape. We get the shape of the graph because we have that y-intercept, okay? Remember when we learned how to graph a line, how many points did we need to graph a line? 2 points. How many points do we need to properly graph this parabola? 3 points. Good. We need 3 points to graph the parabola. Okay, give you one more practice problem, then I'll have you start on your worksheet. Okay, y equals, we're going to do 2, let me see here. Make sure I don't mess this up. Yeah. Let's do 2x squared plus 4x plus 4. Okay? So we're going to do this a little bit quicker. What do we know right away just looking at it? Y-intercept, which is 4. Okay, so put that point there, right? A equals 2, B equals 4, C equals 4. Okay. Your axis of symmetry x equals negative b over 2a. Make sure you're copying this down. You need to be able to refer to it later or you will not be able to complete your homework. You will absolutely forget. All right, so negative b. So that gives me negative 4 over 2a, and a is 2. So we get negative 4 over 4, which gives me negative 1. So my axis of symmetry is at negative 1.
Ms. Murray?
Yes.
Hi, can I have Mark talk to the front office for just a moment?
Okay. All right. So there's my axis of symmetry. Now we have to find our vertex. Our vertex. We have the x is negative 1. So what are we doing to find y? Plug it in. So 2 times negative 1 squared plus 4 times negative 1 plus 4. Shh. Thank you. Okay, we plug the negative 1 in for x. Please make sure you're copying it down. Okay, now when we do this on our calculator, the -1 is squared, not the 2. Remember your order of operations. We do exponents first, right? So this is going to be 2. What's -1 squared? 1. -1 times -1 is 1. So we get y equals 2. Okay. So we're going to go -1, 2, right here. So we need a third point. How are we finding the third point? No, we already got C on there. Yeah, the C is 1 unit away from the axis of symmetry. So we're going to go 1 unit the other way. Again, imagine that you're folding it on that line. So now I have my skinny parabola. Okay, questions? Okay, there's a worksheet in Google Classroom called Standard Form. There's only 4 questions, but they're going to take you longer. Okay.